man, this is really living.
We're committed to the art and nothing can stop us. Not even a train, plane, tractor, all of us as we feel the rhythm inside the marrow of our bones.
Hey guys, Blue Kool-Aid here with you. I'm gonna give you a video. Hey, yesterday I did a video. I posted it, and some of you guys I think kind of seen it. It got kicked back for some reason. I'm still unsure why, but I had to go ahead and just pull it down. There might have been something that was the algorithm picked up or what have you. But I went to post that, and yeah, I actually was talking about what was going on today, and actually the CMEs that were happening yesterday on the sun. I had seen that on SDO, and I was trying to get that out to everybody, but unfortunately after I posted it, it got blocked right away. The algorithm picked something up on it, I guess, like I just said, and then I had to go to work, so I didn't have enough time to go ahead and try to make another video, but It doesn't matter. Anyway, I'm going to bring you guys this information now. Because honestly, guys, I don't care if I bring this stuff to you guys first or second or last. As long as I'm helping somebody see it and understand it. That's all I care about. But anyway, this right here, guys, is the KP level. And we've talked about this multiple times. It's the level of geomagnetic storms. They just rate these things. Obviously, if you look, so you see the color coding here: minor, moderate, strong, severe, extreme. Very similar to a severe thunderstorm or a tornado. Just like typical weather, how it is put onto different levels of intensity. That's exactly what this is. Okay, and as you guys can see, that's a 5. Okay, that is in the minor level. It says minor. Okay, and it hung out there for multiple hours. And I don't know, just because it dipped down. Just because it dipped down here doesn't mean that trend's going to keep that way. I do think that we're going to continue to see these solar winds right now from that coronal hole we were talking about a while. The one that was Earth facing for like a day and a half. So those winds won't go completely away until after that time frame has passed, because it took it like 2.5, 3 days to get here. So once it got here, obviously what was going to come at us was going to get us. So I don't know. I haven't really heard of much any kind of outages or anything. I do know that, like I said, the earthquake stuff is definitely going to ramp up. I haven't checked it yet. We'll check it together here in just a minute. I would almost assume that we're probably still seeing, obviously the earthquakes aren't going to stop, but we might see some bigger level earthquakes, more frequent. And we were already starting to see that anyway. But this is just going to increase it more. So, with that being said, we'll move on here. But, yeah. So, that's a minor geomagnetic storm, is what they consider that. You get to the level 4, which is where this last bar is, they consider that active. Okay. Then you get to the 5, then obviously you go on and up. Now, the further up it gets, obviously, the more effects that we could have from it. Negative effects, I should say. Okay, so what we're going to do now is I'm just going to run you through these real quick. Obviously, you guys are seeing that just is not, that's not a normal signature. It's definitely a storm signature is what I would call it. We look, again, pay attention to the timestamp down here. Okay. That was about 24 hours ago, as I'm making this video now. So we'll go ahead and just use the slide bar. And there's a couple interesting things that I've seen here. One thing I will point out that we did see what a lot of people think is like a cosmic ray anomaly, which very well could be. We seen like a small wave, and then everything stopped for a minute, and then here came the solar wind right behind it. That could have been caused by the Planet X object, but we do know that the cosmic rays are going to increase also because of solar minimum. Now, what do I mean by that? The sun has its own magnetic field. Okay, it stretches out to the, encompasses our solar system. It's what protects us from cosmic rays, for the most part. We do still get them, obviously, but just like the sun's energy can penetrate the Earth's magnetic field, well, cosmic rays from other systems, other galaxies, other stars, what have you, can penetrate the sun's magnetic field, and they call that cosmic rays, and that's what gets into us sometimes. So when we see those signatures, always leaves us to question, was it the Planet X object or was it cosmic rays? And frankly, does it really matter? It does, in the sense that we want to know, because it will affect us differently. It will have us looking in different places. But the effect on what we see as far as physically here isn't going to change much. That's still energy, radiation type of stuff that is getting through, whether it came from the Planet X object or cosmic rays. The effects here on planet Earth are going to be very similar. Anyway, again, let's go ahead and just use this slide bar. As you can see, we get the compression like I've talked about before, and then rapid expansion. Okay, and we're going to get multiple waves of this, guys. This stuff isn't going to slow down. Okay, see how close it's getting to the satellite line, which is that dotted white line around the Earth there. This is a view from the top, looking down onto the Earth. So, and you can see that, how the Earth was really fighting that one off. Okay, and yeah, so I mean, and this is what we would expect when we get hit with, pretty good solar wind and density and stuff. Here's the radiation one, the radiation belts. Now, this is fairly interesting. I talk about this sometimes, because when we see that energy come, it almost looks like our magnetopause reverses when it does that. That's not really a complete reversal. Okay. We had those events before, and that data was scrubbed. There was multiple people that were able to record that before they scrubbed it from the net. But it's still hard to find that data. I do have some of it, and I've shown it before prior in some other videos. It's just proof that it has happened in the past, and it will happen again. Our magnetopause will reverse once in a while. It's just going to happen. So what that means is when it reverses, anything that we, like, say, this is our magnetopause, right? See how the sun is over here, right? And everything's going this way. Well, if our magnetopause reverses, what that means, the sun stays where it's at, right? But then our shields kind of look like this. See how that's doing that behind the Earth there? That's why we kind of look at this kind of funny sometimes. Okay? And then anything that is coming from behind or from the sun direction is getting through. There's nothing there to stop it, is what I'm trying to say. So if our magnetopause and our magnetic field reverse for any length of time, any energy we're getting from the sun direction will make it through into our atmosphere. Okay? Or it would be really extremely easy for it to. So the fear in that is when these reversals do happen, okay, that if the sun had a massive CME or a flare, even a moderate one, while this thing was reversed, the effects that we would have would be pretty severe. Okay? I don't know, like I said, everybody needs to go research the Carrington event. Just go Google that Carrington event. It'll blow your mind. It fried all the telegraph lines almost on the whole freaking planet. So, I mean, that was, it was a big event. It was a flare. Okay. It was a solar event. So anyway, we'll move on here. Now, I'm going to clarify something about these models real quick. Keyword there is model. I have a tendency, I call these things captures a lot. It's just a word, a generic word that I use. If you look at the timestamps on any of these things that we look at, okay, on these particular the ISWA models here, at least these the SWMF models, you're going to see that we get to see a how can I word this? We get to see a visual. That's what I'll call it. We get to see a visual every 4 minutes. Okay? And what do I mean by that? What's the difference between a visual and a capture? Well, a capture is something that would be taken from like a camera. Okay, this is not a camera. I did misspeak, in some of my previous video. I just use it as a general term because it's hard to have to explain this every video, and I want people to understand what I'm talking about. But I also need to make sure that I'm giving you guys, the most accurate information that I can. So, what I'm saying is that this here is a visual. It takes data that the satellites and observatories are collecting. Okay? It's like mathematical numbers, all those kinds of things. And it puts it into a model. Just like a weather forecasting model. If everybody has ever seen a hurricane forecast, you guys can tell that what it does is it'll show you different models. Okay? Say there's a hurricane. Say this is the Earth, and there's oops. Say, well, let's just do it this way. This is my crude United States of America. Okay. So there's a hurricane out here, right? It's circling around. Okay, I might have even spun that the wrong direction. But anyway, one model will show it coming in this way. Another model will show it going that way. And then another will go this way. We see all these spaghetti lines, right? Well, those are models. They're taking data points and they're trying to put it into a visual. Okay? So it takes all these data points and then it puts it into a visual so we have a better understanding of what the data means. It's trying to give us something to look at so our minds can better understand the data itself. And it helps us to predict things because we can kind of see, movement a little bit. So we get a visual every 4 minutes, and then they put it into a time lapse. So all the data every 4 minutes at that particular time stamp is put into this visual pic right here. And then 4 minutes later, it does it again. And then 4 minutes later, it does it again. Okay? Unless they go into safe mode or what have you, and you miss some of the data, then then the time gets kind of messed up. But that's the difference between a visual and a capture. Okay, this isn't a camera. All right. Now, when we look at the Core 2 and stuff like that, those are coronagraphs. Those are they're taking captures. So, but anyway. As we go through this, you're going to see, okay, we're getting hit with these winds, right? I mean, that's pretty good stuff there, guys. I mean, that's hard-hitting stuff. I haven't seen a storm like this in a while. I just have to say that. And it really, we kind of expected this. We didn't know how intense it was going to be, but I did think it was going to be fairly long-lasting because of how big that coronal hole was. So, there's that. Let's just show you this one. This one here is the actual solar wind model itself. You see the directional arrows. And plus, I like this one in particular because of that. That's the actual solar wind speed. That's in kilometers per second. So if we know the kilometers per second, we can actually go back in time and figure out where that energy came from on the sun. And I showed you guys how to do that a few videos back. But as you can see, if you watch this up here, as I'm moving this bar across, you'll see it fluctuate. And I seem to get up to like 800. one time there. So we'll see if we can't catch that one. Now, something else I'm going to show you guys here too, and I've talked about this before. You see this little open area right in the front? Okay, how it's yellow and not red. I do think that when that happens, it's easier for stuff to get through to our atmosphere. And we still have a shield here. Okay, you see the bow shock out here in the front. Anything that can make it past that would have an easier time to get to the Earth's atmosphere. So, yeah. So here we go. Let's go ahead and run this through. And a lot of times what happens with that is, guys, I think if you watch this, you see this? Okay, this is before that hole opened up. Watch, we're going to get hit. See that? We got hit. And then look what happened. We opened up a little bit. We got hit again. And then boom. Let's see how we opened up more that time? And we stay that way this time. And then that's when I think we get the brunt of whatever's coming at us. Because we take such a hit multiple times over and over and over again that it takes the Earth a minute to, correct itself. So while the Earth's correcting its magnetic field, it makes it easier for other stuff to make it in. So that's just my opinion. As you can see, guys, that's pretty rough. If you guys look up there at the wind speed, that says 802. Let's see what else we can find. Let's say 9. Yeah, that's 918. Dude, that's fast. Wow. We'll go compute that in a minute. Let's say 942. That was the last capture. Wow, that's a fast one, guys. 942. I haven't seen one that big in a long time. And I'm going to show you guys something here, too, that's very interesting. That was 942, right? Okay. I have a converter. All right, and I've showed you guys this before, too. What we just looked at was 942 kilometers per second, according to that model. So 942, we'll convert it to miles per hour. What's that give us? 2.1 million, basically. Okay? Million miles per hour. That's fast, guys. So that energy left the sun, basically, yeah, it would basically have left it, 48, yeah, like 3 days ago. So it's exactly right where it should be. Okay? So when we do see that, we can attribute that to that solar, that coronal hole. So if we want to know exactly the time frame it took, we can take that miles per hour, which is 21 or 2.1 million. Okay, and we're told that the sun is 93 million miles away, and I know that there's some people out there that don't believe that, and that's fine. Honestly, it's your guys' opinion. But for what we're doing here, that's the number we're going to use. 93 million divided by 2.1. 44.2 hours ago. Okay, roughly 2 days. So if we go back 2 days from that point, that's when, if that solar wind speed stayed constant and wasn't affected by anything else, we can just get a ballpark. So, then if we went back and looked at the sun, we could look at it, see if there was a coronal hole Earth facing, and there was. I'm not going to take you guys there, but we all know that there was. I already showed it before. Sorry about these stupid ads, guys. I mean, this thing's driving me nuts. My phone did an update, and ever since then, I think that I must have gave it a permission I shouldn't have. But I'm going to take you guys over to here real quick. And, yeah. Let me take you over here. Alright. Yeah. So, we have... Go space weather right here. Okay. This right here is just the space weather website. Obviously, see it says we're in a minor storm G1. See that? Wind speed 680. There it is, a KP level. Okay. Now if we look here, obviously you can see in the yellow line, it shows. Okay. I just want to show you guys this part of it. Okay. Now what I'm going to do, guys, I guess we can go look at the USGS real quick. See if there's anything popping off. I haven't heard of anything yet today, but it isn't saying that it didn't. I'll have to dig some more into that. I'm not going to really go into that right now, guys. I'm going to pause it for a second. Alright, guys, got you back. Hey, I got you over at the SDO. I seen some stuff on the sun that was really kind of crazy odd. I seen this yesterday, and I think a couple people have done a video. I think that they reported on this. Again, this was in my video yesterday. It was just blocked, so I just pulled it down and didn't have time to redo it. So, but as you can see right here, you can watch a filament blow off. Okay, that is a CME. Okay, that filament released and went on out. That was a CME. Now I'm not sure if that was Earth facing or not. I haven't dug into that yet. Haven't had time since I've been home. I just seen so much stuff going on. I wanted to get you guys a video out. Now, if you're looking here, guys, okay, not only did it blow here, but I seen something over here too. And what, you see that? Okay, watch this. Watch. It's coming. Here it comes. Boom. See that? I mean, that was, yeah, that was pretty decent size. So there was a CME on both sides of the sun there. Okay. And as I'm looking at this, the most recent data, and I'm not sure if anybody's reported on this yet, I noticed some funky signatures down here yesterday. Now watch this. Okay. This is odd. So stinking odd. All right. You guys see that? What in the world, man? I don't even know. Okay? Watch this stuff over here. Where did that come from, and what is that reacting, and what's going on with that? Okay, that definitely was some sort of discharge from the sun. Is the sun reacting with something there? Look at it, how it floats around and then boom, goes on out again. And it looks like we had another CME right there at the end. This is the most recent data, guys. The sun's going a little nuts right now. And I don't know why. I do know, I think Venus is hanging around in its orbit. If you go look at LASCO C3, you can see it. But I'm not sure exactly. I mean, that's the position where Venus would be, but it wouldn't be real close. Now, certain alignments, especially with Venus, the sun does react to. I will say that. But this right here is something that was really kind of strange. Okay, now I'm going to slow this down a little bit. Okay, because I really want you guys to see how kind of funky crazy this is. I mean, look at this. Okay, now you can definitely see that the sun's reacting right there. And you're going to, like I said, you're going to see it's almost like flat. I don't understand how energy can look like that coming off of the sun, and then do that, and then float back in like that. Okay, you seeing that? All right, now it's almost as if, now check this out. If this is actually what's going on, that's one heck of a coronal prominence that just erupted into a CME. Okay, and what am I saying? If you follow that line back, it goes almost all the way back to here. That's almost half the distance of that side of the sun. Watch this. Okay, it's impressive. I mean, I don't. You can see the line here. You can kind of follow it back once it does its thing. Okay. I'll zoom in just a little bit more so you guys can see a little bit better. But yeah, watch that. See that? And what I find strange about it is the speed of it is kind of floats back and forth. And now we've seen coronal prominences and sunspots and what have you, do stuff that is very active. But for it to stretch that far, if that's actually a coronal prominence or a sunspot, going all the way back that far across the sun and, doing its thing right there, I just don't. I think something it's reacting to something out here, guys. I really do. See that? That is just all kinds of strange. So, what are we going to do? Well, what we're going to do is I'm going to go look at that in a different angstrom. That was 171. The 171 angstrom gives us some pretty good stuff into the corona because it tends to show a little bit more than others. Now, the 304, it's really good at looking at filament releases. Okay, it'll see it really like pinpoints the filament. At least for the visual that we need from it to get a little bit more precise on what we're talking about here. So, we'll look at that one real quick. And again, guys, this is the SDO. Okay, yeah, I mean, you've seen that eruption. Okay, let's go down here and watch this on the bottom. Yeah, I mean, I really think that was a couple different CMEs right there. You know, is the sun reacting to something out there, or is the sun just having a fit right now? Like a mad child or something. I don't know. All I know is what I can show you, and this is what this is. And in my opinion, that is definitely some sort of a release, but, there's that first one. As you can see, guys, that it's very active right here. These areas of the sun tend to stay pretty active for some reason. I don't know the reasoning. See that? See how that one went off? Okay. And it kind of did it again a second time. And then this one over here, and this is happening right now. This is something that's happening currently. And I wish we could go look at the coronagraph, guys, on LASCO C2, but we can't because it's not updating. I don't know why. Maybe it's in safe mode. It's been like 4 days now over at Seeds. Now we can go look at the regular one, but yeah, that is just, yeah. Definitely something that we have to keep an eye on there, guys. Okay? I think that I don't think it was Earth facing. Okay, I think we might catch a tail end of that, maybe. Maybe we'll look at a different... Let's look at a different angstrom real quick while I got you here. And we'll... Okay, here's the bronze. This one's real good at showing coronal holes and sunspots. Obviously, there's a coronal hole. That's that coronal hole that's giving us the winds now. Yeah, so, and again, like I said, these are different angstroms of light, so it may not pick it up. Only certain angstroms sometimes will pick up different energy, okay, different wavelengths of light. So that doesn't mean that it ain't happening, because that's exactly what it means. It ain't gonna if it picks it up in any angstrom, it's there, okay, because it's not gonna see something that's not there. So now, how intense or what have you, that's why we look at it in different angstroms, guys, because we see stuff at different times, different wavelengths. Certain things only show up in certain wavelengths, and that's why we do it. Filters, same way. This is the filter, right? So people jump all over everybody for using filters. Well, that's how you catch a lot of stuff, okay? It just is. Doesn't mean it ain't there, because it absolutely is there, or that filter wouldn't pick it up. So it's just taking out the background noise out of it for that angstrom. So anyway, I'm going to pause it again for a second. All right, guys, got you back here. This is our current solar data. All right, I show you guys this about every video. We've been talking about this electron flux a lot. See what it did? Okay, that's a lot. Okay, that's a big spike, and it's a long duration. And again, there's our magnetic storm levels. Okay, So you can see very clearly that we were under a geomagnetic storm and still are. Okay, a minor one, at least an active situation right now. So, with that being said, really not a whole lot more here, guys. I mean, it's all about this right now. This solar, this coronal hole that gave us this geomagnetic storm. Okay, are we going to see anything effects from it? I'm assuming we're going to see some earthquakes. I'm sure we probably already are. I just haven't looked at it yet. Yeah. So that would be my main concern. Would be earthquakes and stuff. Maybe some small satellite outages, that kind of thing. In order for it to really affect us drastically, as far as electrical grid outages and stuff like that, this level here would probably have to get up to right about there. Okay, I mean, to get significant ones. Now, if it gets much higher than that, then we're talking mass regional types of outages and stuff like that. But yeah. So, I probably won't put a recap on the end of this one because I basically just showed you all those models anyway. And we will just end it there, guys. Okay. God bless. Yeshua saves, and you can drink this Kool-Aid.